Hey everyone, I'm still setting up. Just want to make sure that everything's up and running. All right, and gonna configure. I'll make sure I'm producing some kind of sound. Good. All right, and so just to quickly go over the plan. So I'm gonna continue from where I left off last time, and I'm a little bright here, but the camera will auto correct. Um, and that's fine. That's good enough. Um, Let me try. Maybe I should darken it a little bit. Hold on. It corrects for the skin tone a little bit. There, I think that would do it. Okay. Hmm. Nah, that's even worse. But whatever. Okay. See if it'll correct now. It's correcting a little bit. There we go. Okay. I think we're good to go now. Anyway, I'm gonna continue with where I left off. We are quickly just housekeeping. This right here is Book of Proof, and this is by Richard Hammock, and this is in the Creative Commons. So if you want to download it, it's listed in the video description. So why don't, you could just do that now. You could also purchase through Barnes and Noble. It's a great book. I highly recommend it, and you could see the answers in the back of the book, so you'll know whether I got something correct before I do. I'm doing the odds, so I'm doing the ones with answers in the back, so we don't damage the integrity of the book. And I myself am a student. This is a class I did not pass, so I'm studying to retake this class, and if anyone else benefits from it, that's great. So let's get into it. All right, and go. Comments. Drop a quick hi in the chat. All right. All right. For those following along, did I call this 1.4? It's we are doing 1.4, not 1.5, though we'll probably be getting to 1.5 today. It's fairly short for 1.4. Okay. Write the following sets by listing their elements between braces. We're doing power sets. So I need a second real quick here to. Now I've done power sets before, but so just a couple of things right here. So we are in 1.4 and let's turn on layers. Okay, this is 1. Can I write any better, please? Thank you. Okay, 1.4. And we're going to just size it, narrow down a little bit. Good. Okay. And now we're going to add. Okay, so we're going to say. So example, and this is going to be 1.7. So the equation is this. The power set, and this it's written with a fancy P, by the way. It's meant to be of A is the is 2 to the absolute value of A. That's going to come in handy. So we have essentially, let's see, make sure you understand that it has answers. In particular, notice that each instance of the equation, power set of A. So basically, the set, the power, there, sorry, the cardinality, let me do it this way. The cardinality of the power set of the set A is equal to the cardinality of A. So basically, in this case, let's just take an example. Again, we're just doing a few examples that are written here. And this is, I just need a refresher. That's why I'm doing the examples before I jump right into that power sets. Okay, 0, 1, 3. Okay. So the way you write it is you write the notice how the top right here we have P and then you have the parenthesis, and it has the A. A is the set. Now, as we know, the sets are written in curly brackets. That's why in the bottom, this right here, this represents A. So we can say that as A, but we can call it anything we want. It's a set. So that's why this notation. So now the cardinality of the set A and the cardinality of the power set of A, these two are the same. So A has three elements, so that would be 2 to the cardinality of A. Cardinality means size, so three items in there, which is equal to 2 to 3, which is equal to 8. We expect we expect 8 ways that we can write this as what was it? What was I doing yesterday? Yeah, the subsets. 8 subsets. The power sets would also be here. Now I want to check something here. Is equal to right. So remember how I made that mistake yesterday where I wrote a subset and I put them in curly braces? I made a power set. Okay, so that's essentially what happened. So we're just gonna do this. So if they say list all of the subsets. So I'm just going to list the subsets. So we're just going to say the empty set, 0. So you're taking your box and then you're breaking it up into lots of little boxes and all the different ways that you can combine it. These are called singletons. Each of these new sets, they are just going to hold one item. And then we're going to go to doubletons. That's going to be 0, comma 1, 0, comma 3, comma 1, comma 3. All right, and then the last one. Okay. All right, now we have 1, 2, 3, 4, 5, 6, 7, 8. Now that is right here. If we're just looking at what I wrote, this, hang on a minute. This right here will be considered listing the elements of a set. So if this is right here, so basically, if they say list the elements of a set, it will be like this. It would give us a set, and then okay, and then we would list the elements. Now, if we did this, if we wanted the power set, if we wanted this part right here, that we take this and we put this in curly braces like that. So now we took the subsets and we put them all in a set, and that is called a power set. Okay. Right. Let's solve some equations. I'm just gonna hide this for a minute. All right. Let's do this. Yeah, everyone's sick right now. Some people have COVID. Some people have MRSA. I'm negative for COVID, and I'm off. I think I'm better with MRSA, but I still got the cough, and this is the kind of cough that just doesn't go away for a while. I've had it in years past. Probably another month till I stop coughing, but it's fine. It's whatever. All right. Okay, so let's pay attention to what we have on the screen here, right? Let's read it out loud. I'm just going to take another marker and we're going to say the power set um, of the set of this set right here. Now, we can just, yeah, so basically we want to know the power set of that set. So what we're going to do is we are going to, well, first of all, we're going to determine how many items are there, figure out the cardinality, then we're going to list them, and then we're going to put curly braces around them. That gives us the power set, right? So Remember how we did that? If we wanted to know the cardinality, the size of the set, we're going to take our old trick. We're going to ignore the exterior parenthesis for now. We're just going to do this. Just going to scratch these, and then we're going to count how many complete braces we have. So we have 1 and we have 2. There are 2 items. Remember that if we wanted to know the cardinality of a set, cardinality means size again. If you wanted to know the cardinality, you put curly braces. So let's just call this A for convenience. So the cardinality of A is going to be 2, and then the size of this, or the number of power sets. So in this case, P of A equals to 2 to the n, where actually that should be 2 to the a, like that. And that's what we were writing out earlier. So, and that is 2, so which is equal to 2 to the power of 2, which is equal to 4. We are expecting 4, okay? Now, I know, like, this is a little brain melty. When I first did this class, I had a hard time wrapping my mind around. You got to write this stuff and practice it and just keep working through it. The reason why some people fail at math, I think, like certainly I've got plenty of F's and W's in math, but for me, what I found was that you didn't give it enough time. It's not that it's like incredibly difficult. Yes, it's dense, and yes, it's unintuitive, but you have to put in the work. If you just fail math and you never cracked open a textbook, well, there's the problem. Okay, and so let's continue here. But there's nothing wrong with failure. You just come back and do it again after you practice it up. You know what I'm saying? Don't repeat the same mistakes twice. So let's start. So now we know this. We want to know the subsets. Now, when we said previously it was a little clunky, why are we suddenly throwing in this power set? It feels suspiciously similar to what we did yesterday. Well, they would simply give us a set and said list the subsets, right? So for math likes to have these neat little things, these characters that you write, and then that signifies something. So instead of writing a set and saying list the elements and put curly braces around it, we simply write this, write that, and we throw the set we want in there. So let's do that. So we're gonna, this is the opening one, and we're gonna say no, or we can do this. Either one is fine. Let's keep it simple. I just like the empty set. That's how that reads, the empty set. And then we have, there's 4 items. It's gonna be the set of A and B. Notice I'm putting in extra curly braces because it already is a set, but what happens is a set that exists within a set that we're pulling out as a subset, you have to put new curly braces. And the reason we don't have it around the empty set, this symbol is identical to this right here. These two mean the same thing. So putting curly braces around it would be saying like you have a box and you have an empty box in the box. We just want the empty box. Empty box, a box, empty box, box with 1 item in it. And that 1 item happens to be a box that has several items in it, but we don't care about that. We're not worried about that right now. All we're worried about is just the exterior. Okay. You know, you study a lot of pure math and you go to Amazon and say, hey, you know, I could work in your warehouse. I know a lot about boxes. Anyway, just kidding. Let's continue here. I don't think they have much of a sense of humor. Let's see here. Here we go. Okay, so now, yes. And then now let's look at real quick. There's one last thing I have to do here, and it's going to look a little confusing, but you know, you should expect it, right? The closing one. So notice now we have 3 curly braces. So we have, this is our closing and opening, right? And then we have our items. You have item 1, item 2, item 3, and a minute. Right. And then item 4. Okay. That's even I had to squint for a minute. When you have these nested boxes, it's easy to screw up the parentheses or the curly braces. Anyway, so don't blow through these things. Take your time. Review your work twice, submit it once. All right. I believe that's the answer. Let's find out. All right. Okay. 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 Yes. Uh-huh. Perfect. The book agrees. All right, good. Yay! So yeah, pretty much what I said correctly in terms of why we have the symbol of the power set. At least in for the purposes that we're doing it. I mean, anything I say, I'm sure someone can throw out a well, actually. And again, I am just a student. I'm fairly ignorant on these things. So if I can get an answer right, that's good news for me. All right, that means I understand something, but again, my knowledge, my understanding of these things is very superficial. All right. Next question. Power set. Oh, by the way, this is how they write it. This fancy P, and they actually have a fancier P. It's the same thing. I draw it with a simplified fancy P, but either way, it's a symbol for the power set. But that's what it looks like in the book. Isn't that nice? Okay, just writing this out. All right. The once you understand this, it's not that bad. You're more likely to trip up on screwing up the number of curly braces you put and so forth. But if your work is legible enough, then you usually get at least partial credit. Here we go. And I gotta tell you, it must be very tough being a math professor, especially at the I guess at any level. But they must do a lot of squinting and be like, well, I gotta give them something or they're not gonna get anything. Yeah, believe me, professors, because they can't literally fail everyone, right? That wouldn't be good. That doesn't look good on paper for them. And one way that I can alter the size of the appearance of the curly braces. It's easier for me mentally to read it. But again, it's still just curly braces. Don't do that when you're actually using LaTeX or whatever to write the code for this. All right. Mhm. Okay. And I now I'm gonna write it out of order because I skipped it. I skipped the empty set. So that right there, the third item, is an empty set. I should have put that in the front, but it doesn't matter. Mm-mm, that's too many. When you're doing the complete set like this, you don't have to put the curly braces. Notice how like I put the ones around 5. It doesn't have the curly braces. That's because it is an item that we pulled out of the box, and sometimes that item that we pull out could be a box. But since we're pulling it out of our main box and putting in a new sub box, we have to put curly braces. But when we talk about the main box, that means the full set, you just write the full set as the item here, except at the very end, we're still going to put the closing curly brace. That's the closing curly brace for the entire set. Now again, the third item here is the empty set. I usually put that in the front, but whatever. I mean, I could erase and put it there, but it doesn't really matter. Your items, whatever order you put them in this box, it's like as long as you don't put them in different sub boxes where they don't belong, the actual list of items 1, 2, 3, 4 is the same as 4, 3, 2, 1. And again, this is in terms of like listing the subsets. You could list, like usually I go empty set, singletons, doubletons, tripletons, whatever. And finally the final size set. But you could, reverse your order if you want. You could start with the full set and then work your way down, I suppose. Um, because it doesn't fundamentally change anything in terms of, yeah, the order is different. But if you put them in the wrong boxes, then that becomes a problem. All right, let's. I'm just reading my curly braces, making sure I didn't put any too many or too few here. Okay, that's set. Scratch that. That has two good. Right. Yes. And then we have that closing. All right, I believe that's correct. Let's find out. I gotta memorize which page the answers start on the back. And if you download the book, you'll see the answers before me, so you will know if I'm working in the right direction or if I'm messing it up. And the book's in the description link. There we go. Right. Everything's correct. So book agrees. All right. The only difference is they put it in the order from empty set through the complete set, and I put the empty set on as a third item. Okay, let's do 5. Okay, this is where it starts to get interesting. So whenever you have a question that, like some questions we had nested items, and I said, don't worry about what's in that box. They're trying to throw you off with that. That's one thing. This is different. This is where you actually have to figure out the nesting of it. And the way you do that, well, in this case, would be I would want to solve this part first. So let's solve that first, right? So let's just take that down here. So the power set of the item 2. Now, right. So we want the cardinality first. The cardinality of a singleton item floating in a box is going to be, that's 1. So what we're going to do is, in this case, you just count the number of items in the box. 2 is the only item floating in that box. All right, so that's 1. And then the power set size, remember, P is A, the absolute value of A, or the cardinality of A. In this case, A is a set. So, I wrote that wrong. Power set of set of A. The cardinality, the size, equals to 2. This is an important thing to remember. Okay, and in our case, it's going to be 2 to the 1, which is 2. So we expect 2 distinct items to be in our so 2 different subsets in our power set. And I'm sure you can figure out which that is. So for this specific one, right, the answer is going to be like this. So we're just writing out the power sets. We know we expect 2 items. The first item is the empty set, and the second item is the complete set. And then we're going to close the braces. All right. So you are good at math when you finally know how to write good curly braces, right? Okay. So I'm not there yet by a long shot. Okay, so yeah, we have two items. Now, we want the power set of this set. So to make this easier on our minds, we're just gonna take this, and that is the same thing. We just solved it, that's all. And we drop the P, and instead now we have the power set. And then we're gonna say we want the power set of this set. And again, we're gonna do the cardinality first. And then we are going to write it out. Okay. In the cardinality here, there's going to be, let's see here, right again, cardinality of the power set of A, and any set, in this case, we're just calling it A. We can call it S or C, and then just plug that in there, is equal to 2 to the cardinality of A. So we have, in order to find out how many items are going to be in our power set, we have to solve 2 to the A. The cardinality of A, so A is equal to the set, and the set is just this. And once again, to find out the cardinality, we just drop these two and count the number of items in braces, including empty items that are listed as an item, because here, this is equal to this right here. Just another set of curly braces. That's the same thing. So there's two items. So A equals to 2. A equals to 2. So this equals to 2 to the 2, which is 4. We're expecting 4 items in our power set. We're going to open up our curly braces, and we're going to start listing. Now, we have an empty set, but it's not this, okay? This is not equal to that. Not equal to. All right? And the reason is this right here is we are applying the power set effect to this, right? And so we have to, and now this item in here exists as a listed item. Even though it's an empty set, it's an empty box that exists within the box, so it counts as an item. This right here refers to an empty box, but not an empty box with an empty box in it. So this next one is going to be the empty box with the empty box in it. Okay? And if this is a little brain melty, it's okay. It is, that's just how it rolls. So this one, again, for every item that we put in here, we boxify it here. We put a new box around it. So our curly braces are, except for the final set. The full set is it's the complete box. We don't have to put a box around the complete box. And then, yeah, so that's the complete box. And now the closing brace. I like to make those bigger. Yeah, so that way I can just visualize it better. So we have 1, 2, 3, and 4 items. Okay? So take those off. Now I have to again review my work. Did I write what I wanted to write? Okay, yes. Looks good to me. Let's find out. Check in the book. Okay, answers are on 294. And we're working off of page 17. All right. Question number 5. The book agrees. All right. Continuing. Good stuff. Get a drink real quick. So it sounds so gravelly. Yeah, 294 is our page for the answers. Feel free to download the book. It's free. And then you can either study together or you could look at the answers and place wagers on whether I'm going to get it right or wrong. All right. Okay. Yeah, I need to go back for a second here. Okay. Cartesian products. So now the next part is gonna be here, and again, like when so now it's an ensemble cast. We're using elements from several different things to try and create what we want to do here. This question, they want us so we learn how to play with each of these items like a symphony. By the way, yeah, while I don't study this, I've taken this course in the past because I didn't pass it because I had to focus on work. I'm a professional landscaper slash handyman, so yeah. But I do enjoy doing this, and when you're on your own business, you have to take care of your clients first before you take care of yourself. So, continuing where I'm at, right. So, what we want to do is before we start writing out the Cartesian product, ordered pairs, then we first are going to find out what are the power sets of those items. So, both have two items in them, so we're expecting four. So the first, let's just go with this power set. We want to create the set. We want to drop that P, right? So that's going to equal. Now we're just going to get a new set here. Power set of, subset of A, subset of B. There we go. Okay, so the first one. And the second one. Okay. So I've written out both sets, and then we just have to take the Cartesian product of that. Okay, and then we're gonna call. We're just gonna call them. We're gonna name them. We're gonna call this one big A, and we're gonna call this one or alpha and beta. That's fine. We're just gonna use alpha and beta for them. Now the next part we're gonna say is AX B. All right. Now the reason I did that is because otherwise I would have had to write the whole sets times that. This is one of those things where I basically saying, let this set here be A. In other words, I gave the set a name, and now I could work within that, right? So instead of like taking a person and describing them every time you talk about them by describing every single cell in their body, you simply refer to them by their name. So that's what we're doing here. Okay, here we go. So we're gonna order them. Hang on a minute. I want to check on how I did some ordered pairs. Okay, 1 second here. All right. Okay, so when we do ordering pairs, this is on page 9. The way we got this is we still have to. So an ordered pair list is going to create a new set, right? We're taking two sets and we're multiplying them, and then we're getting an ordered pair out of it, essentially. That's the way to think about it. And an ordered pair can also be graphed. And this, not everything can be graphed. I mean, like basically it's x comma b, x y coordinates, and yeah, I guess in a sense anything could be graphed that way. But then you have to figure out by which format. I mean, how would you graph empty set sign? How would you graph a b? When you got one now. Well, for instance, the your numbers for the let's see here. But anyway, it doesn't matter. This is the kind of thing that you can do where you on one side you can have the time spent, on the other side you can have the money or the money made per hour, something like that. You can calculate or miles traveled and just their speed or something like that. But you don't really go about it this way. For our this is just something we got to do, and we'll worry about the why later. Don't get ever caught up in the why because I mean, like when you get to a high enough level, yeah, sure, that's what you think about. But at a low enough level, don't stop your teacher and say, "Well, how do we know that 2 + 2 is 4?" And they could write you a math proof or refer to some axioms and so forth. But you get caught in the weeds and you get nowhere. A1 times B1. Okay, then we're gonna go A1 times B2. Okay, A1 times B3. A1 times B4. Notice with the commas, this is still an ordered pair. It's just one item or two items for parentheses, an X and a Y. And that item could itself be containing multiple items within it. Okay. What? Okay, hold on. Just work out texting me. Hang on. Let me take care of this real quick. Okay, I'm fine. Okay, sorry. Okay. Okay. Okay, good. All right, everything's fine. Continuing as I was. Right. So we went through A1 to B4. And so the other thing that you need to know is that how many distinct items do we expect to create here? Well, the way you do it is you just take the number of the cardinality of A, which is A cardinality, which is 4, and the cardinality of B, which is 4, and then you multiply them, which is we're expecting 16 items there. So 16 things, 16 sets of open and closed parentheses. Okay, so we got 4. Now we're multiplying A times B. In this case, our A is going to we're going to go to A2 next. So I can keep the B's. And I'm simply going to move the A. All right, A2 times B1. Um, A2, there we go, times B2. A3, no, A2 times B3. And then A2 times B4. Good. All right, we're getting there. So first one, A1 times B2. Let's see, I'm just checking making sure I'm not making any obvious mistakes. All right, and then good, good. Yeah, looks right. Good. All right. Moving on. Let's continue with A3, which is there we go. A3 times B1. A3 times B2, A3 times B3. There we go. A3 times B4. Okay, and finally, A4 A4 times B1, A4, all right, A4 times B2. Okay, it's my charging brick for my phone. A4. Okay, hold on. Let's adjust this. There we go. Keep it neat. Keep it readable at least. A4 times B3. A4 times B4. Closing of our curly brace. Yeah, 16. All right. And this is where you go back and you look, you check, you look for mistakes. You try to consider everything that you wrote. Is there opening, closing, curly braces? Yes, we're good. We are good here. What's this? Let's see here. One. Right, that is a correct. That is a curly brace. Good. 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 All right. That should be correct. 1.4. Okay. All right, book agrees. Good. I had to be thorough. But yeah, when I looked at it immediately, I saw that most likely agreed, but I had to read one for one and make sure that everything was as I wanted it to be. Good. And the book and everything that went down was good. That was long. That was long. Um, mhm. All right. Okay. We are getting there. All right. 9. The power set. By the way, just watching this, just okay. Let me talk about for a second. I want to pause before I continue, and I want to talk about methods of learning that, in my experience, specifically in math, that work best. Right. So, for instance, if you're sitting and just listening to a lecture by a professor or something like that, you're going to maybe retain 10% of it, unless it's material that's intuitive. If it's anything complicated, yeah, you could expect maybe 10% retention the next day. If you are sitting there and taking notes of the professor and you don't review the notes, maybe 20% retention, depends upon how fast they talk in their notes. You review the notes, depending on how much you review, your retention obviously can go up pretty highly. But if you were to afterwards solve problems that are assigned, like, and not just like, God, professors know you're busy, right? They don't even assign you like a whole set. They'll give you like two or three questions from every section. Like at 1.4, we'd answer maybe three or four, maybe, and then we go to the next section. But no, just do every question in there. At least do the ones with answers and the ones you're assigned with homework, and then your retention might be like maybe 70 or 80%. I find the highest retention, between 80 and 90%, is when you talk and you try to explain this while doing it. This is why I do this. Is really for my own benefit in a sense, because I understand that when I work my way through it and I talk my way through it and I try to explain it in a way that someone that perhaps hasn't taken this class could understand it from watching it, that forces me to really dig into it to try to understand the process. And that significantly increases your retention rate. Just keep that in mind. So yeah, and people that say that they are visual learners that have to just I have to see what's going on. I mean, yeah, there's truth in that, but math, you can't learn math just by watching videos. You have to sit there and you have to do it by hand. Otherwise, like I'm not saying obviously yeah, watch videos, but you have to work these equations yourself or other equations, and it's the only way to really get ahead in math. Otherwise, it's impossible to retain anything. It's very hard to memorize formula because there's so many ways and means of doing things, and you have to be able to work your way through them. And if you can't, rote memorization will only take you so far. All right, so here we go. So we want the power set of AB times X. So here's what we're going to do this. This is actually, if we go back for a second here, right, we multiplied a power set by a power set previously. In this case, it kind of inverts it. Now we are doing basically it's saying this, and then we're going to say equals A equals beta, right? Alpha beta, I'm just assigning that. So in this case, we're going to say the power set of A cross B. Okay, cross multiplication here, we have A times B. So, and this is something else, cross multiplication is something you do in linear algebra. There's also dot multiplication, and not just the symbols, but it refers to the types and ways that you can do multiplication. So, let's do this right now. We want to get our Yeah, we want to cross multiply them first, and then we're going to get the power set. Yeah, let me check something real quick. Rolling back. Occasionally I jump back and then look at previous descriptions of the previous pages. If you want a good diagram to look what it looks like, you could look at example 1.3 on page 9, how you list ordered pairs, essentially. So what we're going to do here, let's see here. Yeah, so in this case, you have a row times a column, and that's your cross multiplication. Um, yeah, let's solve this. All right, so we're going to go A1. So we're going to go like this. Let's see, A cross B, which equals to A1, which is A, times B, which is just 0. Okay, and then we're going to say A2 times B, which is again 0, B 0. We're ordering pairs. Okay, so that's what we did. So we multiplied 2 by, so basically we had 2 items in the first set in set A, 1 item in set B, and then we cross multiplied them. We had our ordered pair now. We've ordered pairs. So now we want the power set of this. We want the power set of this set right. All right. So treating the parentheses as each as a single item at the ordered pairs, that should be correct. So in this case, the power sets should be still bigger, opening curly brace. This should be correct. Closing brace. Wait a minute. There's a closing brace. So let's take a look real quick here. Yeah, we have empty set. We have the first item as a set. We have another singleton, and then we have the full set. That, I think, is the correct answer. The book agrees. All right, good. All right, now. All right. So sometimes I use words in a somewhat peculiar way in terms of when reading a set notation. I still, I mean, I know them well enough to where what I describe is correct in the end. Just keep in mind you might hear slightly different lexicon from people. So I'm gonna write this out. Let's make this nice and neat. Okay, so you can kind of shortcut your way through this. We're not gonna do that though. We're gonna solve the full thing, and then afterwards we're gonna answer the question. Now you're gonna see very quickly that we don't. Okay, maybe we'll shortcut a little bit, but I'll explain what's going on. So the set X, I'm just going to put dots so you know what I'm saying. Okay. The set X is a subset of the power set of the set 1, 2, 3, such that the cardinality of X is less than or equal to 1. All right? That's what it means. Okay, is that clear? Okay, so basically they want singletons or less as the result. We do the power set, we stop after we finish the singletons. Okay, so that should be pretty straightforward. That's what I was saying. Do I do the full set or the power set of the set? And I was like, I don't know. Let's just do that. We are, instead of, what I could do is we can go down here and write the set. And so the power set of this set would be, so 2. I guess we'll do the full thing. Why not? Those are your singletons. This right here is the answer. I can just stop right there, right? But we're not going to do that. We're just going to do the full thing. So the empty set and the singletons. At least that's again. When I say that I think that's the answer, I could absolutely be wrong. I could misread something or misspeak. Keep that in mind. So I mean, I make plenty of mistakes. 1, 2, 2, 3, and then 1, 3. Doubletons, comma, and then closing brace. All right, let's just check that real fast. The power set of 1, 2, 3 should be 8 items. 1, 2, 3, 4, 5, 6, 7, 8. There's 8 items. Good. Starting with the empty set, we have our singletons 1, 2, and 3. Doubletons of 1, 2, 2, 3, and 1, 3. And then the full set of 1, 2, 3, closing brace. So we want the size, the cardinality, that's the right here. We want that. The absolute value bars. And by the way, here's a great thing. If you ever want to become a mathematician, think about it this way. If you want to, you have the benefit of one day developing a math system, and then you can take pre-existing symbols and redefine them so you can keep trolling college students. Just think about the advantages of that. Anyway, what happens is the absolute value bars are also cardinality bars. The absolute value, of course, being if you take it of a negative number, you get the same number but as a positive. Take the positive number, then you get a positive. But in this case, cardinality means size. It's similar in the sense that, like, when you say, like, let's say -2, what is -2, right? You're short 2 units, right? You have, say, you're like, hey, I need 2 more units. I'm -2 items, right? So the absolute value is these are 2 things that you need. So in this sense, we're also talking about counting the number of the units, or and in this case, but it's all different because here it's the size. So when we say this, in other words, the box can contain the only that size. So in this case, we say the size of the box is limited to less than or equal to 1. In other words, the items in the new sub boxes. So we're going to say the answer to this is going to be, and by the way, we have to write this as a set. So here we go. All right. Attention to detail helps also. The more attention to detail you have, the easier it is to pick things up. You look what's different, what's the same. You try to feel your way through it, and then you can catch things that you might otherwise miss. All right. Wait a minute. X is a subset where the card. I did not answer that correctly, and I'm trying to figure out why. Let's see what they did here. This is 11. Yeah. Okay, let's see here. Set X is a subset of the power set, okay, such that the absolute value of X is less than or equal to 1. I think I got it. I think I know what they're saying. Okay. Okay. So the set X is a. No, no. Hang on. I think it's the subset. I think I figured out what I did wrong. Okay. X is the subset of the power set A such that X, the cardinality of X is less than or equal to 1. So X is a subset. So we take the power set and then we have to create subsets of the power set. So yeah, okay. Let's just do that. It helps that I did this part. So now we're going to continue here. All right, I'm just going to cut this out. We can take the first part. Okay, yeah. So basically, what we're doing now is this. We're creating a new subset out of the power set. And all we're just going to do is we're going to say, starts with an empty set. In other words, we're putting in a new round of boxes. Everything that exists here, hang on a minute. I messed that up. Gotta switch tools here. Okay, for emphasis, let's do that again. Okay, everything that exists here goes in a new box. And we start again with empty box. So we have the empty set, and then we have the box of the previous empty set. It's in the box, and now we have one. But now, again, we're reboxifying everything. We're putting new boxes around everything because we're creating a subsets of an existing set. So this kind of harkens back to the previous chapter. Here we go. Okay. Okay. And yeah. Sorry, daylight savings is still messing with me. Okay. I believe that's the correct answer. I didn't try to memorize the look at this. Oh, Ralph. Ralph is here. Let's put Ralph up here for a minute. Let's see if I can show him. Oh, Ralph. Hey, good to see you, buddy. We knew each other from skating. I guess it's what you make out of it. It's no harder than skating in a sense if you devote enough time to doing it. Yeah, it's hard, but it's very well written. It's very dense. See, the thing is, the higher up you go, then the more dense things are, more mathy, because you're expected to be able to just take the stuff that you learned in previous classes. But it's not terrible. I try to explain it in ways that even someone not familiar with this could understand. Anyway, I don't know how good of a job I'm doing, but let's see here. Meanwhile, I'm trying to learn too. So learn off my mistakes, guys. Okay, this has now been corrected. So that is corrected. So essentially, let's go back so we could remember this better. What we're saying here was this. This is a new set X is a subset of A. Remember this, we're calling this A. The power set of this is A. So this right here, we're going to say let A be equal to this. Actually, well, it already has curly braces. So let A be equal. So we're just giving it a name for convenience. Um, so now what we're going to do is go back and read it. So X is a subset of the power set A, and such that the absolute value of X is less than or equal to 1. Now, this is the part that tripped me up. I went into the singletons direction. What's happening is that when you're recreating when you're creating new subsets, each of these is one small individual box. Even if it has multiple things, it's Russian matryoshka dolls. You know, they're nested. But because we're creating subsets, they're technically each count as one. So that was meant to be a bit of a tricky question. If they just left that part off, I probably would have gotten it correctly, or at least it would have been easier for me to figure it out. But and again, maybe that's absolutely necessary. But yeah, the way I see it, this it's something that I now understand, so it's better. Uh, um. Anyway, here we go, Ralph. I'll try to do a better job on defining the definition of the symbols. Yeah, it's like some of the stuff again. If you're watching, from this stream, like I can't like redefine everything for every stream just because it would just take too long. A lot of it is if you go back to like my first and second streams, I spend a lot more time defining certain things, and that way, you kind of have to have this accumulated knowledge. So there's always going to be a bit of that explanation gap, which I try to fill in as much as I can for every stream. But even then, I do realize that I can't quite cover everything every time from the beginning. But look at that. We have now um, gotten to section B. And okay. Okay. A cross B. Oh boy. Okay. This is a little different. This is gonna take a bit of thinking. And okay, so let the cardinality of A be M. So the size of A, we're just gonna call that M. M could be whatever. I mean, it's a number, but we don't know what it is. And frankly, the book doesn't care. We were gonna write the answer in terms of M. So we want to know the cardinality of the power set of the power set of the power set of A. All right. To answer this, we're just gonna work from inside out. All right. Where am I? Hang on. I need to. There's a definition that I had earlier. So This is where I'm gonna need it now. Okay. Power set of B has 2 to the n subsets. Okay. Okay. A to the m, then A. M technically is 2 to the n also, but we don't know what n is. So I mean, no, I said that wrong. In general, if this is on example 13 on page 13, if the cardinality of B is equal to n, then B has 2 to the n subsets. So to the n has a 2. Okay, we're going to need that. A has 2 to the m subsets. So the power set of A, let's see here. So then, okay, power set of A would have 2 to the n subsets. So in other words, and they wanted to know, so if you want to know the size of this thing, the size of it, 2 to the m, and the power set of that, 2 to the m, and the power set of that would be like this. I think that would be correct. At least I'm in the right ballpark. I should be, I think. Um, and the cardinality of that is so. Hang on a minute. So power set of the power set of the power set of 2 to the m. Right. I do think that's the answer. Let's find out. 13. Okay. You're a wizard, Harry. I got it. I got it. I got the right answer. Now, they actually threw curly braces around it here, but this is because it's powers. Whenever PEMDAS, a parenthesis. But the other thing is that these are exponents. When you're doing exponents, you don't necessarily have to throw parentheses around it because the way it works is it would still get you the same answer basically. So yeah, that's fine. That's good. That's excellent. All right. So we got it. Yeah. All right. Good. Now let's do some more wizardry here. The cardinality, or the size, of the power set of A cross B. Let the cardinality of A equal to M and the cardinality of B equal to N. Okay, so now, so we do interior. The cardinality of A cross B is A cross B. What would be that? So wait a minute. When you have, I'm throwing numbers in my head. So like, let's say hypothetically, we have A would have 2 items and B would have 2 items, and then we would cross multiply them to get ordered sets. So let's see here, 1 and 0, say 2 are A and B. So let's see here, 1. Let's say here both have 0 and 1. So that would be 0. So that would be 4. So that would be that the cardinality of A times B would be 4. So, and it's the same thing in the sense that the cardinality of A, in this case, let's say I said earlier was 2. In this case, B would be 2 is 4. But if it was different, the orders are like 3 and 3, you would still get it the same way. So And then the other thing is, remember what we said, the power set, the cardinality of the power set of A. Did I write that right? I think I did. Is equal to 2 to the cardinality of A. So that means the answer should be 2 to the m times n. Okay, I believe that's the answer. Okay, let's find out. Yeah, we got it. Yes, we're doing good. Yeah. All right. Like when I took this, I kind of blew through this because we didn't have time. I wasn't able to figure out either of these questions, and I just kind of like, okay, whatever. I tried to figure them out, but I couldn't. And this wasn't like the one of the assigned ones, so it didn't really matter. But it's important to understand this. All right, and this is section 1.4b, by the way. I'm looking to finish 1.4. All right. All right. Okay. Now remember how I screwed this one up last time? Let's see if I could just pay attention, get this one right. It's somewhat similar to the previous one. All right. All right. Okay. The cardinality of the set of X containing the power set A such that the cardinality of X is less than or equal to 1. The cardinality of the power, okay. Well, we're going to have to see what is the, and yeah. Let A be equal to M. Okay, so we're going to define it in terms of M. So we want X contains, set of X's, set X contains the power set of A. All right, where the size of the X, I think they're asking for singletons on this one, possibly. Center equal to 1. And the cardinality of that, well, how many singletons would they have? This is a hard one. Set X contains the power sets of A. Well, what is the power set of A? Well, the only thing that we can say in the power set of A, let's see what we have, what we're given to work with. Power set of A is equal to the cardinality of the power set of A is equal to A 2 to the A. And we know which is also equal to 2 to the M. Okay? So the cardinality of where X contains the power set of A such that X is less than or equal to 1. We might just have to define it in terms of 2M. All right. Cardinality of I think it's 2M. 1.4. I got this one wrong, but I probably wouldn't have gotten it. I know what it means now that I think about it. It's similar to what we had it before. We take the set and we create a subset. The set X contains the power set of A, where the cardinality of the X is less than or equal to 1, means that they want to create the subsets. So when you create like a power set of a power set, you can create it in a way to where you can take a power set and then you can just run the singletons. That means, so like, you could take a set and it would say like 1, 2. Let's see here. So basically, here's what they're saying. I'm just going to give you the answer, explain this, how this means. Let's say, okay, so let's say, for example, E is the set, and E's a bad one. Let's use B instead. Beta, okay. And we're just going to say, okay, we're just going to say that's the set, right? Now, if we want to say the power set of it, so we're going to say, this is probably what I could have done. Power set of B, which is equal to this. Closing one. 1, 2, 3, 4, 5, 6, 7, 8. Good. So basically, the let's see here, the power set of the cardinality of the power set of B is equal to 2 to the cardinality of B. So, and there's 3 items, so the cardinality of B is equal to 3, which is equal to 2 to the third, which is equal to 8. Right. So this is how I could have solved this to have gotten it right correctly. I'm just thinking this now. I'm working my way backwards. So so that answers a couple of things. That answers what the power set would have been, and we know now. The next thing is, let's read the other part. We go back to the question, right? X contains the power set, in this case we can say power set B, such that the cardinality of X is less than or equal to 1. So what they're saying is, if we wanted to take this right here, right, there's 8 items, and we can list them by taking each of those and putting them in a single box, where then we can double them up, and then we can do this all the way up till we have the full set. And so we would go to 8, and this would just be like just extremely huge. So what they're saying is we just want the singletons of the power set. So that means we're going to take each of those items and list them. But when you do that, if you want to say, I'm just going to write this right here, X, here, and just write this in black. The cardinality of X contains the power set of B such that the cardinality of X is less than or equal to 1. The answer to this is what it would look like. And I already got this one on the previous question, so I know this is correct, but we need this. So opening brace, and then we have empty. Now, let's see. I don't remember if I got it right on the first time or after analyzing it. I think it was after analyzing it. But I know, either way, I now got it. I need to stop writing chicken scratch. So Closing brace. Okay. So now I wrote this out. We wanted to know what the x. Now here's what I did. We wanted to know what the cardinality of this was, not necessarily what they actually were. So the actual thing what I did there would have been like this. Yeah, this we didn't want the cardinality. The way I answered it right now is just saying the set. Now, if we wanted the cardinality of this, if you wanted this cardinality, or adding a, if you wanted to know the cardinality of this, then we simply would count them. There's a 1, 2, 3, 4, 5, 6, 7, 8, 9. 9, because we redid them in the boxes. Now, this is, again, they only want singletons of this new set. And remember, usually we're working of sets of 1, 2, 3. This is a set of 8 now because it is a power set. And powering through power sets exponentially increases the size of the set. So the answer to that would be 9. And if we go back here, finally, we can answer the question. We have the cardinality of the set X containing the power set of A such that the cardinality of X is less than or equal to 1. So what that is, if you go here, is the cardinality of A equals to 2 to the cardinality of the power set of A refers cardinality of the power set of A equals to 2 to the cardinality of A. And we're defining the cardinality of A in terms of M. And so it's 2 to the M. In this case, the original one would have been 8. But because we are reboxing them and each one becomes a new singleton, the full set is now considered a base level of the new power set. But they don't want us to write this huge set with, but instead they're just going to say stick to the first level, the singletons. And of course, because this brand new set contains a new empty box, the null set, we have to, the final answer is this. M plus 1, 9. Okay? And the previous one. That's the answer. Yeah, it's crazy. Welcome to the nut house. Yeah. Right. That is correct. Ralph just said that. Here we go. Let me show him. Hey, there you go. Ralph said it too. Good. Yeah. Good job, Ralph. All right. Here we go. Good. All right. That was 91. Okay. A times the empty set. 19. The last one. So here we go. Now, I don't know, Ralph, maybe you've done math or maybe you looked the back of the book. Either way, you got it right. All right, here we go. 19. Okay, good. Right. Okay. Power set. Cardinality of the power set of the power set of the power set of A times the empty set. And let A let cardinality of A equal to M. Okay. All right. We'll keep that as our little secret, Ralph. Good. All right. So here we go. I got to think about this one. All right. The question then becomes is, can you multiply A by an empty set? Gotta think about that. I think because I made that mistake earlier. I don't remember the exact way I messed that up. Let's see here. I'm just gonna look at a few examples they have. So I just want to know if I could even do that part. Empty set. Come on, I like think. Um, so in this case, it's just referring to an empty set, but it's not like a set of an empty set. So is it like a times zero, so to speak? That's what I'm trying to decide on here. Um, okay. I have to go back. I'm reviewing work that I've done in the past here. I'm looking at the previous questions in the book, trying to find. This was one that stumped me before, and I got it wrong. It's similar to this. So again, that is, yeah. I'm just gonna say it right now. So we don't really do stuff like this, right? We don't really do that, and that's what it's asking us. What is the power set of that? Um, I'm just gonna say no, no. That's what I think is the answer. Um, and that's not the correct answer. Okay, okay, and well, okay, okay. I answered correctly, but for the wrong. Okay, I answered correctly, but the part that I answered correctly is wrong. This is this, right? That's true. So I was correct about that. But um, then we're gonna boxify that. That's where I was wrong. We are gonna throw some boxes around here. So let's just continue this here. Cardinality of the power set of the power set of the power set of empty set. So we've made a bit of progress. So we have the cardinality. Now, what is the cardinality of the power set of an empty set? Well, when you have a set of an empty set, so that now it's one item, so now it's two. So this part, let's see here, cardinality of an empty set. In this case, if we wanted to know the cardinality of this, um, or I should say that's wrong. The power set of this, the power set. And then we can get the cardinality by looking at it, or I'll just tell you what it is, but it's this. This is the power set. So now there's two items. You have the box itself, the empty box, and then you have the previous empty box, which has now been boxified. So we have two items. So let's continue that. The cardinality of the power set of the power set of this set. Hold on, no, too many, too many. Okay, we dropped this P, so that we got this one done, and then so we got that. Now we also wait a minute. Yeah, so that was one. power set of, so you have the power set of the empty set is that, okay? Power set. So the power set of the power set of, so we dropped one of the p's and we filled it in with this. So now we're going to say this. You want the power set of this. I better not be messing this up. And so then the power set, this is going to get confusing. I'm just going to move this to the side here. I'm going to say this part right here. This is going to go here. So then we're going to have the power set. All right. What's the power set there? Well, let's write that out. Again, we are going to have a set, empty set, and then we have the previous empty box has been boxified, and the original empty box is now double boxified. Technically, when you count the whole set, it's triple boxified. That's my own word, by the way. Don't go around saying to teachers that you are boxifying things, okay? That's an Olegism. All right, so now we have the cardinality of the power set of, that's a P, by the way. Looks like a D, but it's a P. Here we go. The empty box, and this is a set now. Here we go. We have, all right. All right, now, final boxification here. And then it'll give us the cardinality. So final boxification, a new empty box. The previous empty box has been boxified here. Here we go. Double boxified here. I really should stop saying that word. Okay. There we go. Yeah. Okay. And the cardinality of this set, which is 4. We have, remember how the rule of how we check for cardinalities? We scratch the exterior and we count the complete ones. We have 1, another one, another one, and another one. These things are, there's 4 items. So the answer is 4. The cardinality is 4 is the final answer. Okay, so that is correct. And I just had to, like I said, my answer was correct in the sense that I answered the interior, and then I just kind of blew off everything else. I should have really unpackaged it, and now that I've unpackaged it correctly, then that is the correct answer. Okay, so yeah, that is it for this section. Let's take a look here. That gets us through 19. Next time. Okay, well. Okay, yeah, the 1.5. All right, that's good. We're going to have union and intersection, and then we can have subtraction. So, yeah, this is not going to be so bad. The next section, again, we're going to change the gears a little bit. We're going to do something a little bit different. And, yeah, hopefully tomorrow, now that the sun sets at 5, I mean, I do work in the dark. I put lights up, but, you know, I can't use power equipment too late. People get mad. So that's why I can't work every day too late. So, yeah, I'll probably be on around 7 or 8 tomorrow. We'll see if we can get through section 1.5. We have more sketching. Yeah, it's not too bad. Yeah, yeah, this is fine. Okay, yeah, so we have one, two, three sketches, and then we have two questions with 9 parts each. All right, it's not gonna be too bad. All right, hope you guys enjoyed today's stream. Growlithe, it was good to see you, and I hope to see you next time. Have a good night.